Hello world, it's Rational Pi. I'm here today with a fancy new haircut. Got my sides and my back shaved, and I got this nice little purple streak in my hair. Hope you guys like it, but I think I know you will. Well, I am here today to start our very basic delve into search algorithms and artificial intelligence. The primary algorithm that we're going to be looking at is what's called the A-star algorithm. And what it does is it takes you from node A to your goal node using a path cost and a node heuristic. We'll go into those topics later on. But what we're going to be doing is, our goal here is to utilize a real-world example on how this type of algorithm can actually be used. And what we're going to be doing is we're going to be taking the 30 teams of the National Basketball Association, analyzing their current division structure, and seeing if it makes sense or if it should be changed. You may be thinking to yourself, well, that seems pretty simple. Well, with the change from Seattle to Oklahoma City, the Northwest Division of the Western Conference doesn't really make a whole lot of sense. You'll see here in just a second. But we're going to be using the eye test, we're going to be using the A-star algorithm, and we're just going to be using straight statistics to see if we can find a good solution or if they should just leave the current structure alone. So I'm going to cut here to my Visio sheet here, and it has the 30 nodes overlaid upon a map of the United States. Every node stands for a current team in the NBA. So one starts at Portland, Oregon, and then just goes all the way around across the country. Every node should have at least 4 paths coming from it. And what that means is that it's the 4 paths of the closest cities to them. The only exception is from 1 to 30, and we did that so that we could have a closed loop system. So you may notice that some nodes have a certain color, some nodes have a different color. The nodes that share the color currently are in the same divisions, like for example Portland, Utah, Denver, Oklahoma City, and Minnesota are all in a current division. The nodes, or the paths between the 2 nodes in the same division, are shared the same color. Paths that are black are between 2 nodes that are from different divisions. Every path and every node have what's called an attribute. The paths have a path cost, and the nodes have what's called a node heuristic. And those are what is going to be used to find the best path from one node to another. And we'll go over that in a future video. But what are these different path costs and these node heuristics? Well, let's go ahead and go over that in my nice little Excel spreadsheet here. So, the node heuristic is a... Ooh, I accidentally messed that up there. So let's go and fix that. So the node heuristic is a node cost or a node function. And that function, in our sense here, is going to be a 5-year win percentage of that team. Which, Oklahoma City, my favorite team, is looking pretty good with a 67% win percentage over the last 5 years. Very nice, Thunder. And then the node, or the path costs, is going to be the driving mileage between each city. And as you notice, I spent some time here, and the black ones are between 2 cities that are not in the same division, and then they share the same colors as they do in my Visio spreadsheet. This is what's going to ultimately decide the best path between one point and another. And that's what's also going to help us decide, does the current division make sense, or does the ones that we create make sense? And what we're eventually going to do is we're looking for 5 teams that are geographically similar and that distribute the win percentage across the whole country. We don't want a division that has 5 teams that are so much better than the rest of the other divisions, because then not all the teams that deserve to go to the playoffs will. So we're looking to create a little bit of parity with that as well. So eventually we're going to multiply a path cost by a node heuristic, and that's what's going to give us 1 of 5 set attributes. And then we're going to average the set attributes to see if there's a nice balance between the 6 divisions that we create. It may not make a whole lot of sense now, but as we move forward, I think that it will start becoming clear. So the first test that I would like to do upon our little division test here is just a basic eye test. And I went ahead and did that before I made this video, and I'm hoping that will make a little bit of sense as we move forward. Now this is just talking about the geographic location of each team. I haven't honestly looked into the win percentage just based on the eye test. So if we're just looking at the map here, it makes sense that 1, 2, 3, 4, 5 will all be in the same division because they're all on the West Coast, they're all relatively close to each other, and most of them share paths to one another. Okay, great. And then we could go 6, 7, 8, 9, 10 because they're all in the lower Midwest. 11, 12, 13, 14, 15 as they're all right here in this general area. 16, 17, 18, 19, 20 are all along the East Coast, very similar to what we did over here. And then 21, 22, 23, 24, 25, they're all right here in the Northeast. And then 26 through 30, they're all right here. So I kind of did this on purpose to where 1 through 5, 6 through 10 would all be the eye test solution of the divisions of the NBA. And that would make a lot of sense if the NBA did it this way. But is it the best method? That's what we're going to be doing in our next few videos. We're going to be looking into statistics based on the geographical location and for the win percentage of the teams, and the A-star method, and that's what we're going to do there. Is it's going to be twofold. We're going to test the little traveling salesman problem, trying to find the best path from node 1 to node 30 without that link from 1 to 30. Obviously that'd be the easiest path because it goes straight there. And we're going to find out if the sets that we create statistically and through the eye test are the ones that make sense. I hope you're excited for this. I know I am. There's going to be multiple artificial intelligence series that I'm going to be doing, but I wanted to start with the search methods because that's what a lot of artificial intelligence classes that you take for the first time are going to be really focusing on, is the ability of your program to learn how to navigate a certain network. Again, a like and subscribe is always appreciated. Pinkie Pie would definitely appreciate it. Any comments regarding my method, any logic that I should be using, or just any questions or comments in general are always appreciated. And I will see you in the next video. Look at this purple, isn't that just awesome? See you guys later.